Hello and welcome to your stats warm-up. So this is basically just kind of a rundown of some of the major stuff from the last unit, but let's take a look at what we have. So Wile E. Coyote is pursuing the Roadrunner across Great Britain towards Scotland. Sounds about right. The Roadrunner chooses his route randomly such that there's a probability of 0.8 that he takes the high road and 0.2 that he takes the low road. If he takes the high road, the probability that he's caught is 0.01. If he takes the low road, the probability he gets caught is 0.05. Create a tree diagram to model this situation. What is the probability the Roadrunner is caught? Okay, so the first choice that we have is high road versus low road. And it tells us that there's an 8% chance, or sorry, an 80% chance that he's taking the high road, which means there's a 20% chance he's taking the low road. All right. If he takes the high road, the probability that he gets caught is 0.01, which means the probability, I'm just going to say free, is 0.99. And then down here, if he takes the low road, the probability he gets caught is 0.05, which means the probability he stays free is 0.95. So the question asks, what is the probability the Roadrunner is caught? And we can see that there are two branches that end with that result. So we have to calculate the probability of those two branches and then add them together. So we're left with 80% times 1% plus 20% times 5%. All right. And then it's just a matter of kind of putting that into your calculator. 0.80 times 0.01. I didn't need a calculator for that. That's embarrassing. And then 0.20 times 0.05 is this right here. So then our combined probability is 0.018. All right, that's the total probability that the Roadrunner is caught. Now, number 2 says find the probability that he took the high road given he was caught. So the probability of high given being caught. Using the conditional probability formula, we know this is the probability of being caught. All right, the given becomes the bottom of our fraction over the probability of going high and being caught. All right, so we just found the probability of being caught. So that's going to go down right here. And we also found the probability of taking the high road and being caught. All right, that's this branch, which means it's this value, and that's going to go in to the top of our fraction. All right, so that tells us that we're really looking at 0.008 over 0.018. 0.008 divided by 0.018, and it works out to be basically 44%. All right. So if he was caught, the probability that he took the high road was 44%. And at first that might be a little confusing, like, but wait, there's only a 1% chance here and there's a 5% chance here. But the Roadrunner takes the high road a lot more frequently. So it makes it have a heavier weight because it's being multiplied by this 0.8 here. All right. Internet sites often vanish or move so that references to them can't be followed. 13% of internet sites are lost within 2 years of publication. If a paper contains 7 internet references, what is the probability that at least one of them doesn't work 2 years later? And then it says it's easier to take advantage of complements, right? And that's because of this phrase, at least one, because one could mean that 1 doesn't work, or it could mean that 2 don't work, or 3 don't work, or 4 don't work, or 5 don't work, or 6 don't work, or 7 don't work. And we don't want to have to calculate all of those separately. Instead, we can say, well, what's 1 minus the probability that 0 don't work? All right, and that's equivalent to the probability of 1, 2, 3, 4, 5, 6, or 7. All right, so if a site has a 13% chance of disappearing, there's an 87% chance it stays. And if we want to know what's the chance that all 7 stay, so the odds that all 7 stay is 0.87 to the 7th power. All right, that's the odds that all 7 stay. So 0.87 to the 7th power is like 33773. 3773. So that's the odds that all 7 stay. So the odds that at least 1 goes away is 1 minus this 0.3773, which works out to be 0.6227. All right, so that would be my final answer there. And again, just another example of it's easier to take advantage of complements instead of having to do each one of these separately and adding them all together. All right, so at least 1 is usually a good sign that it's easier to kind of do a complement. Number 4, a poker player holds a flush when all 5 cards in the hand belong to the same suit. What is the probability of being dealt a spade flush? So what's the probability of the first card being a spade, the second, the third, so on and so forth? Well, the probability of the first card being a spade is 13 out of 52, because there are 13 spades in the deck. There are 13 hearts, there are 13 diamonds, there are 13 clubs. There's 13 of each suit. So the first one being a spade is 13 out of 52. The second one being a spade is now 12 out of 51. The third one being a spade is 11 out of 50 because each time we're taking away one of the spades, so we have less options. And then we have 10 out of 49, and we have 9 out of 48. All right, so if we're doing that on the calculator, we basically have 13 times 12 times 11 times 10 times 9 divided by 52 times 51 times 50 times 49 times 48. And that gives us, notice that's exponential scientific notation, so that's e to the negative 4. So 0.004952. Or in short, pretty small. All right, and that makes sense because a flush is a good hand. So if we're just dealing you 5 cards and that's it, and you have to get the same suit on all 5 of them, that's a pretty low likelihood because it's hard to do that. Now, using your answer from above, what's the probability of being dealt a flush in any suit? Well, that's just the probability of a spade flush plus the probability of a heart flush plus the probability of a diamond flush plus the probability of a club flush. Now, each of those are going to have the same exact value. So basically, we can just take this number here and multiply it by 4. All right, and that's going to give us a 0.00198. All right, which is basically just this number times 4 because there are 4 different suits in the deck. So this is specifically getting a spade flush. This is getting a flush of any suit. So still pretty hard, but a little more likely. Number 6, a recent census at a major university revealed that 40% of its students mainly used Macs. The rest mainly used PCs. At the time of the census, 67% of the school students were undergraduates. The rest were graduates. In the census, 23% of the respondents were graduate students who said they had used PCs as their primary computers. Suppose you select a student at random from among those who are part of the census and learn that the student primarily uses a Mac. Find the probability that this person is a graduate student. All right, so let's focus on this question here. They say, suppose we select our student at random from the census and learn that they use a Mac. So this is now our given. Find the probability that the person is a graduate student. All right, so this question is really asking, what's the probability of being a graduate student given that you use a Mac? Which means we need to know the probability of using a Mac, and we need to know the probability of being a grad student and using a Mac. Now, the first part is super easy. All right, the probability of using a Mac, they tell us that 40% of the population uses a Mac. So we know that 40% of our population is using a Mac. All right, now, as far as this part up here, well, it tells us that 67% are undergrads, which must mean that 33% are graduates. All right. It tells us that 23% of all students were graduates with PCs. And if we know that 33% are graduate students and 23% are graduates with PCs, that must mean that it's 10% that are graduates with Macs. All right, so these two are adding together to give us this right here. All right, so the probability of being a grad student and having a Mac is 10%. All right, so this is basically 1/4. So our final answer is just going to be 0.25 there. All right, so this one's a little trickier because the numbers are sort of hidden. But if you kind of start with the formula and say, okay, what are the pieces I need? Or basically start with the question, what am I trying to find? And then extending that out to the formula, you can say, all right, well, probability of a Mac they actually give me. And then grad and Mac is a little more hidden, but they do give you enough information that you can kind of work backwards and figure out what that is. All right, so that would be our final answer. All right, hope this was useful. As always, if you have any questions, just let me know and we'll go from there. All right, bye.